hours. On behalf of Apple LAN, hello. Welcome everybody to today's presentation on optical LAN, smart buildings, and Internet of Things. My name is John Hoover. I am a board chair with Apple LAN, and I have the pleasure of being the moderator with you all today on today's presentation. But before we get into it, there are some housekeeping things. So we do have everybody on mute right now, but we want to hear from you. We want you to get involved and have a two-way dialogue. So please, if you have questions, use the Zoom QA feature and write your questions in there. We're going to block out a solid 10 minutes at the end and get through these questions. Next, your screen will display antitrust and no solicitation policy and a legal disclaimer. Please take a moment and review those. There's going to be a copy provided in the PDF of the slides of today's presentation, and that will all get distributed to you after the completion of this webinar. Now, with that, let's go ahead and introduce our speakers. And we got a fantastic panel for you to cover this topic. From DIRT, we have Paul Mills, and he's going to give a what's the connection requirements for IoT in smart buildings? From AECOM, we got Mike Holborn. He's going to give the architect and engineer perspective of some of the design considerations for smart buildings and IoT. Next up, we're going to have Gayla Arendelle. She is from Corning, and she's going to cover the electronics. How do you connect not only the OLTs, ONTs, and switches, but the things that they connect down to as well. And then we'll close things out with Juan Pablo Borre from Panduit, and he's going to cover the infrastructure, the layer one, and even get into some of the powering considerations for IoT and smart buildings. Now, before I turn it over to our expert panels, I just wanted to kind of set the foundation for this conversation because it's a daunting task. It's a challenging one. And unfortunately, sometimes there are some failures involved. And, they can come about in several different manners. I found this great article from Fortune magazine that kind of laid out some of these challenges and the complications. When you're dealing with smart buildings and IoTs, you all have considerations relative to security and privacy. It's a complex environment, so that's going to be tough to deal with. We're connecting things that are real-time, mission critical, so the performance of the connectivities is very important and crucial. And, there's a lot of talk of everything's in the cloud. It's not as simple as that. We actually do have physical infrastructure and connectivity down in these buildings that need to be taken into consideration. And then, there's the human factor. And much of these systems are very complex. So sometimes the skill sets of the existing IT and networking guys may not be up to speed. And you need to be flexible. They're constantly changing, constantly innovating. So it's not set in stone. You got to be able to be flexible. And then, we're just by definition, Internet of Things, there's a lot of moving parts. So that, once again, the complexity of getting everything to work together is tough. And okay, great. We got AI. We got all these great overlays to help us humans not make mistakes, but nonetheless, humans need to be ready to jump in and take control and to fix things. So we need to make these networks as simple as possible so humans can operate them. So with that said, how can optical LAN simplify the underlying network and infrastructure, and how can it provide a foundation that's more reliable and secure and scalable? And then how can we accomplish all this in a more sustainable manner? And that's what I believe our expert panel is going to answer for you today. So with that, let me go ahead and turn this over to Paul Mills, and he'll get us all started on this conversation.
Hey everybody, thanks John, and thank you to everybody for attending this webinar. As John mentioned, I actually work for a company called DIRT. DIRT is actually an acronym for doing it right this time. And we are a industrialized interior construction manufacturer providing interior solutions to various vertical markets, including hospitality, healthcare, commercial and education spaces. And really, as part of that solution, we are providing what we class as connected infrastructure, and that's what I'm responsible for at DIRT, which includes modular power and modular network solutions. What I wanted to talk about first and foremost really is how have we come about this smart building conversation. So if we can move on to the next slide, we've actually been building the same way for the last 200 years. But the demands of buildings are actually changing dramatically, especially since COVID. The way that spaces are being used now has changed, and there is a much more demand now for automation, ownership, scalability, speed, and as John mentioned, obviously sustainability. We're all looking towards this zero carbon emission. So I really wanted to talk about the size of the market. And as you can see from this chart, in North America alone last year, the market was roughly $30 billion. And that is looking to grow now to over $400 billion globally. So this is an enormous market that we need to address. And if I present this to clients, I ask them what is their definition of a smart building, everybody comes back with a different definition. But the key things that we really want to touch upon with smart buildings is power and energy, health and well-being, life and property safety, connectivity, cybersecurity, and the big one, sustainability. So in a short definition, I would say that smart buildings are living connected ecosystems of architecture, design, and operations, and ultimately together they align the building needs to the business. Next slide, please. So one of the challenges we have, and this really comes from my side of the business on construction, is that people are asking now for adaptable, agile interior spaces, but a lot of the time the network or even the power infrastructure is actually tied back to the base build. And by having that network or power cabling tied back to the base build, we lose a lot of the flexibility and scalability for the future. So ultimately, when it comes to smart building connectivity, the change needs to happen easily, effectively, and sustainably. And with my co-presenters today, you'll see some of the technologies that are now available that we put forward as LAN that really can support the interior space and provide the connectivity that buildings require. Next slide, please. So when we talk about connectivity, if we look at buildings today, there are a lot of services and devices that actually sit on a network, be it energy management, be it HVAC, intelligent lighting, elevators, telephony, audio-visual systems. Really, we have intelligent services as part of the intelligent building. And the key things that we need to make sure, and I'll repeat this time and time again, is that if we're having sustainable smart buildings for the future, and I tend not to use the term future-proof, I talk about future-ready, they need to be scalable, agile, and flexible. But another key aspect of it is they also need to be secure. So the key things that I look at when I'm looking at a smart building opportunity and the connectivity is the client will always need fast and reliable internet connectivity. We class the network now as the fourth utility. That term has been used for a number of years now, and it is still appropriate now. High bandwidth connectivity, because all of these services are being added onto the network, there is more and more pressure actually on the network infrastructure, and higher bandwidths are required, especially now with things like 5G cellular communications. We're talking Wi-Fi 6, we're talking Wi-Fi 7 in the future, 4K and 8K audio-visual systems. The system needs to be scalable. It's no good putting a network infrastructure in for day one requirements. Ultimately, we have to look at day two and beyond. So how can we build an infrastructure that has that scalability and it's easily scalable? As technology moves forward, obviously, sorry, back one slide again. As technology moves forward, the network infrastructure has to be able to adopt those new technologies. It is completely useless having a network infrastructure in that cannot take on new technologies. It has to be energy efficient, It has to be sustainable. Obviously, these are the key things that we're looking at. But also it has to integrate with other building systems. This is the whole idea of a smart building, is that it can adapt and integrate with other building systems. Cybersecurity is a big must. I read an article recently in the education space where cybersecurity is impacting education, and it is costing billions of dollars every year, where schools can no longer use their internet or their computer services because of cybersecurity. But from a building owner or a business owner's perspective, smart buildings need to really enhance the comfort of the occupants. It needs to be a way of potentially bringing people back into an office environment rather than working from home. But ultimately, it needs to support productivity growth. You can have all of these great services within the building, but the business owner, they want to be able to see productivity growth from introducing these type of technologies. And a big thing is downtime. The last thing you want is the network to go down. So again, I think Mike will be discussing about downtime with these type of technologies and how we can support that using the fiber to the edge or the optical LAN solutions. But the main thing is it's no good introducing all of these new technologies if it's going to cost more. So we need to have solutions that are cost comparative to more traditional connectivity solutions. And that is a key thing that we look at from both a operational aspect of it, but also from a capital expenditure. Next slide. So I wanted to give you just a couple of pictures here of some of the installations that we've done. And this is the type of technology that will be discussed later on. And OLAN is the term we use for optical LAN. People use the term fiber D, PON, fiber networks. Ultimately, we're looking at a horizontal connectivity infrastructure that uses fiber as far as we can into the work area. So we're trying to replace as much of the copper cabling in the horizontal space with fiber cabling. And really that network needs to be able to support data, voice, security, everything else that traditional copper cabling would support. And ultimately, as I've said, we need to be able to have an energy efficient solution. We need to have the occupancy comfort, operational efficiencies, automation, which is a big thing now. And one of the key benefits of this type of technology is that it can be managed from a single pane of glass. It's got centralized management. So again, when we're looking at campus environments, rather than having multiple closets, we can actually manage all of this network from a single location. And then ultimately, the network security is a big thing for us. Next slide. So this is the big talking point at the moment with smart buildings. How can it impact sustainability? And when we talk about sustainability, we're talking about two key things here: embodied carbon and operational carbon. And the difference between the two is that embodied carbon is the carbon that's actually emitted to build the building. That includes taking the raw materials out of the ground, transporting them to a manufacturing plant, manufacturing the product, transporting it to site, getting workmen on site to actually build the building, the actual materials being used. So how can this type of technology support a reduction in embodied carbon? And then from that, once the client has actually moved into the building, we're looking at operational carbon. How can we have a more energy efficient solution that reduces the amount of carbon to actually run that network and run that building? And again, we'll be covering that in later slides. But ultimately, the key things that we can do is, because of the benefits of this type of technology, we can reduce things like IDF closets. And by reducing IDF closets, we can reduce the amount of crack units or cooling that's required and the amount of power that's required. So that has an immediate impact on sustainability and carbon emissions. Fiber cable is a much less toxic material than copper cables. And to actually manufacture it, it produces far less carbon than traditional copper cables solutions. Another key thing we look at is the longevity of a traditional copper solution. If we look at historical data, the copper cabling is actually ripped out and replaced every 7 to 10 years. And that is mainly due to the fact that it now has no longer has the capabilities for the bandwidth requirements. Fiber optic cabling is a 30+ year infrastructure. And then on the back end of that, the electronics that we use with this type of technology really is a more energy efficient solution, and we can reduce the carbon emissions using these types of electronics. I'm now going to hand it over to Mike Colburn. Mike is actually going to be talking about network design considerations. Just to confuse things more, I'm an Englishman in Austin, Texas, and Mike is an American in the UK. Thanks, Mike.
Thanks, Paul. Very good overview. Really appreciate that. And I think a lot of the topics we're all going to be talking about are going to have a lot in common. So I'm Mike Colburn, Associate Director of Smart Buildings for AECOM in London, as Paul said. AECOM's Building and Places Division provides architecture and MEP engineering, project management, sustainability, digital consulting services across a wide range of markets and verticals, which gives us a pretty good exposure to a wide variety of building and system types, from individual rooms and spaces to buildings, campuses, and even cities. So next slide, please. My daily role centers around smart building consulting with a wide range of verticals, from healthcare clients, government agencies, commercial office developers, education and campus clients. And one of the things that we do with all of our clients is ask them, what does a smart building mean to you? How do we work together to develop this brief of what a smart building is? And oftentimes our clients talk about the apps, the user interfaces, the digital pieces that people see, that they interact with. But behind all of that is data, data and software, orchestration, making things happen. Behind that are all of the physical digital systems that are coming together, sitting on a network. So behind all the devices is the digital infrastructure. So one of the most fundamental things that we do when we're looking at smart buildings with our clients is we try to understand at the back of all of that, at the very base of the foundation, what does the digital infrastructure need to do? And so when we think about smart buildings and the digital infrastructure supporting those, we think about things like, what are the value drivers? Why are we doing this? What is the goal? What's the driver for spending this money, this investment on smart buildings? What kind of wide range of connectivity requirements does this infrastructure need to fit? Device placement, right? For IoT devices, how does where we put those devices impact the type of infrastructure that's needed? The uptime and the difference between operational technology, or OT, versus information technology, or IT. And then lastly, for my talk will be, how do smart building certifications fit into this whole picture? So if we dive right into why are we doing these things on the next slide, we'll see, as we've talked with all of our clients, as we look at the industry, as we participate in some of the professional associations, what we hear are that the four main drivers are cost reduction. So clients are looking to, in particular, oftentimes reduce their operating costs, their OpEx, through integrating smarter buildings, but they're also looking to figure out if they can maybe streamline their portfolio, get more use out of their existing spaces. So that cost reduction is a big piece. Over the last 5 years, especially, sustainability and the awareness of smart buildings and networks and all the different decisions we make, how they affect sustainability, has become a very large driver. Operational efficiency, which gets into the how do you arrive at operating expense savings, but also gets into the how do you realize more sustainability through more efficient operation of your facilities, your processes, as well as the systems themselves. And then finally, but definitely not least important, are the actual user improvements, the user experience, the lived experience, in making life better, more efficient, more joyful, healthier for the users of the spaces. So if we go to the next slide, we'll talk a little bit about what some of those connectivity requirements are that are that we have for smart buildings. So, of course, a lot of smart building devices, PoE devices, they're still looking for, a traditional category cable, possibly with PoE or other forms of low voltage power, which we'll hear a little bit later about on this presentation. So we need the ability to serve, category cable to devices, of course, but not everything has a wire. There's a lot of need for wireless devices, wireless access points. Definitely, wireless requires wires, right? So how do we get high bandwidth, highly flexible, upgradable connectivity in place for wireless access points that we would put in place today as well into the future? Wireless gateways, so not Wi-Fi, but things like Bluetooth for location services potentially, wireless mesh for mesh devices, so gateways for services like Zigbee and Z-Wave, very common in automation, especially in the residential space, but also in certain commercial applications. Low power wide area networks, which again, especially in multi-building or campus environments. And last, but certainly not least for smart buildings, is the need to have good coverage for public and potentially for private LTE for campuses. Next slide. So when we're thinking about IoT devices and smart buildings in particular, we think about what are the properties of these devices. And one of the most common properties of IoT devices is the need to install them in often far-flung locations, on the roof of a building, at the edge of a parking lot, in a parking garage. And often these locations don't really support having an IDF or a comms closet or even cabinet near them. And so looking for, and asking questions about our network architecture, how do we support especially those devices that we need at a distance? Fiber certainly is a great answer, but in particular, optical LAN as an overall technology meets those needs really well. And then from the bandwidth nature, yes, there are some IoT devices, things that are in the AV space or security with CCTV cameras that might have higher bandwidth needs, but a lot of IoT and building controls devices need to communicate occasionally in kind of a peaky nature when they're transmitting or receiving. And again, this distributed nature, the nature of the bandwidth, all very well suited to optical LAN. We'll hear a bit more about the cabling and the active electronics and some of these benefits in a follow-on. Next slide. So Paul mentioned the idea of uptime. So one of the things to think about is, while IT, information technology, is often mission critical, especially in office buildings, knowledge workers needing to be able to access data. Of course, that can become mission critical. There are lots of applications where IT can be mission critical. Operational technology, things like building systems, HVAC, the ability to light a space, to operate lifts, security, letting people in and out of buildings, the way your building functions is always mission critical. So I think that's one of the distinctions with smart buildings, is when you start putting these building systems onto networks, you need to think about the fact that an integrator going out and getting potentially in some cases more of a consumer grade switch and saying, great, we've got our own stood up silo network for cybersecurity concerns, and it's all right here, it's all very contained. When that happens, especially, it's not even enterprise grade, right? So we look at what are the uptime requirements, and one of the benefits of optical LAN is active equipment comes from the carrier space. It's an evolution of the sort of fiber to the home technology, and this carrier grade uptime or availability is typically 1 to 2 levels above even enterprise, where with enterprise you might have 3 nines, and with carrier grade optical LAN technology you might have 5 nines of uptime. So this is really important, can't be kind of stated enough how important that is for operational technology. Next slide. So one of the last things I wanted to talk about is a fairly new idea in the area of smart building, which is certifications. And over about the last 3 years, we've seen the emergence, slow emergence, but emergence of certifications for smart buildings. And this table here talks about, some of the various certifications that have already been in the building space, things that you might be familiar with, like LEED or BREEAM, things you might not be familiar with, or maybe you are, like Neighbors, BOMA 360, WELL. Great certifications, great way to understand how a building is performing. But now with Spire, as an example, which is a telecommunications industry association and UL joint effort, and WiredScore associated with SmartScore, SmartScore associated with the WiredScore entity, we now have the ability to look at how do things like connectivity, in particular media used, the coverage, the security, the expansion ability, which Optical LAN has a really great message about expansion ability and resilience, all fit within a certification scheme. So that's a great thing to look into now. And with that, I think I turn it over to Gayla. Is that right?
Yes, thank you very much, Mike.
Thank you, Gayla.
So yes, my name is Gayla Arundel. I am the current chair of LAN, and also I work with Corning Optical Communications in the market development function. And so today I'm going to talk with you about some of that network equipment that Mike was referring to, and also some of the sort of end device connectivity options there are in an optical LAN network. So next slide. So really and truly what we're doing here is kind of drilling down into what is optical LAN and comparing it to some of the legacy type of LAN networks there are today that involve the copper category cable. So most of us are familiar with legacy copper LAN, where we have distributed switches in IDFs or telecom closets, and PoE switches are there as well. And then we go to each and every device with a dedicated run of copper category cable. And the limitations here for PoE and for copper is that you can go maximum up to about 100 meters from the IDF to each and every device. With the optical LAN network, we're greatly simplifying the network and using the ability to go much longer distances over single mode fiber. So basically what we're doing is centralizing optical switches in the MDF, the main distribution frame. And then if you're just using single mode fiber and remotely powering your edge device in a zone, you can go up to 20 kilometers there. And at the edge, you'll have some sort of a network operating terminal in a zone that will then connect to multiple edge devices. So here you could start to see one time how in a legacy network with the dedicated copper wires to each and every device, we're greatly simplifying and eliminating, significant amounts of cabling, which plays very well into the whole sustainability and cost effectiveness of an optical LAN network. Also, there's the option to do what we call remote power. So in that case, you can remotely power through a low voltage type of network, in the zone, the optical network terminal. And with that, we can use this hybrid cable, which includes fiber and power, or you could run separate fiber and power if needed. But in this way, we can actually centralize not just the switches, but the power in the MDF. So if we go to the next slide, I'll talk a little bit more now about what goes on in the MDF in terms of the active equipment. So there are a couple options here. One of the options is this technology called PON or GPON, which involves an optical line terminal, and then it also involves these PLC passive splitters. In the PON technology, we have the traditional PON, as they call it, which is GPON, which is about 2.5 gigabits per second downstream and 1.2 upstream. The newer technology that has come out with respect to PON is this XGS PON, which is a 10 gig symmetrical stream. So again, these optical line terminals are put into the MDF. If you're using PON, you need to use these passive splitters that require no power, they're pretty much just passively splitting the light into 1 to say 32 or 1 to even 64 type streams. So again, this really efficiently uses up the way that you can cable your infrastructure over the single mode fiber. Another option for an MDF sort of optical switch is an active Ethernet switch. And these go from 1 gig all the way, up to 100 gig or above. And again, with this, we can use optical fiber all the way to the edge, and at the zone, we can then switch to the short lengths of cable to connect the devices. And then the third option that you have, which are on the market today, are these software-defined switches. So these software-defined switches are agnostic to the type of technology. So they can do GPON, they can do the XGS-PON, or they can do active Ethernet. And basically, they give you a lot of flexibility in terms of going with the GPON technology or without it, in terms, if you don't use the GPON, you don't have PLC splitters, so then you have a one-to-one to the zone. But again, at the zone, we're connecting to multiple devices at the edge. So those are some of the options that we see in the MDF. And as Mike said, these switches a lot of them came from the carrier side of the business with this 5 nines and above reliability. So they're very, very reliable switches that feed this optical LAN type of network. So next slide, we'll talk about the remote power options a little bit. I know that we'll have Juan Pablo drill down a little bit more into this when we talk about the new class 4 fault managed power. But right now, a lot of this is being done today with remote power in the class 2 and 3, which is a 56-volt DC power that delivers up to 100 watts of power to the edge. So again, you centralize the remote power in the MDF, and then from there you can go with, as I said, this hybrid power and fiber cable, where we can have both copper conductors and single mode fiber under one jacket, which enables you to really extend the architecture up to and even beyond about 600 meters, which again is much longer distances than you have with the traditional sort of copper network that we had. So here you just see a couple options on the market today, and some photos of this hybrid cable with the fiber and the power under one jacket, which can be managed very effectively in traditional sort of network architecture apparatus. Then last but not least, we're going to go in the next slide to the edge, or what happens at the zone. So this is really a fiber to the edge or fiber to the zone kind of optical LAN technology we're referring to. Because many of the devices, as Mike said, still require that PoE copper cable interface. So what we're doing is taking what we call an optical network terminal. These can be, these can be for a PON network or for an active Ethernet network, and we're putting them in a zone, and they're being fed by a single mode fiber. And then from this device, you can connect to multiple devices at the edge. Typically, this is a short sort of copper patch cord, about 3 to 6 meters long. And there are many different options on the market today for, how many ports these ONTs can deliver and the amount of power or PoE that they can deliver to the edge device. You'll see here some options with multiple ports. You can have an in-wall version. You can have them indoor or indoor-outdoor mounted. And again, I just want to give you some ideas here from these photos about the options that are available in terms of mounting and where you place these optical network terminals in your network. So you can put them in a NEMA box. If it's an outdoor rated sort of environment, you can put them in a hotel. Many times hotels are using this technology and they're placed right behind the TV. If you move the TV, you might start to see some of these electronics there. They can go above the ceiling or in cable trays or inside of the wall. And as Paul told you about with the dirt walls, very often they're put inside of the dirt walls if they're using dirt furniture, or they can be placed outdoors. Again, this 600 meters and beyond distance really helps us to get to the far edges of the network. So those are some of the equipment options that we have. And now I think on the next slide, I'm going to hand you over to Juan Pablo from Panduit, who will talk a little bit more about the passive infrastructure and the powering choices.
Thank you, Gayla. Hello, everyone, and thank you for joining us today. As Gayla mentioned, I will talk about two main topics in the next few minutes. One is the importance of the physical infrastructure portion on the optical LANs, and then I will address also the new choices that we have to power devices. Next slide, please. So here we have the topology of an optical LAN, and the physical infrastructure is everything. Next, please. Is everything what is between the OLT and the ONT on the optical LANs. Components include fiber cable, splitters, connectors, pigtails, and others. All of them are passive, but the importance is next, please. The passive components are as important as the active. If you think about optical LAN, you can compare with a car, and the passive side is like the wheels of the car. You can have the best car, but if you have the proper wheels, this car won't advance, and we won't behave as it is desired. So it is important to take in account that this passive infrastructure is important. It needs to be designed, installed, deployed, and tested according to standard and best practices. Again, if we don't do that, because sometimes or most of the time we focus on the devices, the best cameras, the best active, the best wireless access points with the latest technology, but we don't care about how they are connected. And it is important to do, because at the end it can conduct on a poor performance, and the network can't behave as it is decided. Next, please. So we have some benefits. It is secure. Why? Fiber optics are less susceptible to electromagnetic interference. So in many cases, we can install the fiber optic within the same infrastructure with other cabling, for example, power cabling. It doesn't depend on grounding and bonding. I'm not saying that grounding and bonding is not important. It needs to be grounding and bonded, but the performance of the network doesn't depend on how it is in case we have it. Obviously, in terms of security, light pulses are much more difficult to intercept and decode compared to electrical and radio waves. When you connect to a wireless network, for example, it is easy for a hacker or someone that can that wants to damage you to intercept and decode this information. As I mentioned before, it can be deployed in almost all environments. In the case of this image, you can see that in the power lines can be deploy the fiber optics, and it won't have any type of problems when you transmit. No safety risk for staff and network devices, and improve information security. As I mentioned before, light pulses are difficult to intercept. Next slide, please. Scalable. Scalability is important. Why? Because you can have low to high density solutions. It doesn't matter if you have a small network deployment or a big and network deployment. You can have from one or few drops to many or thousands of drops. You also have different ways to terminate the solutions. It being in the field, or there's a way to terminate the fiber. You can do it from a field termination standpoint, or you can do it in a pre-terminated. Sometimes these solutions come from the manufacturer in that way, so it secures that the solutions will be in the best option, and will be the performance will be the best. Again, it's suitable for all network sizes. If you need to grow, drops can easily be added, and in today's day, is and speed of installation is something that you need to take in account, because again, in the past, what we think is that fiber is difficult to terminate, and you need experienced people to do this termination. But today we have many different options, and it is not as difficult as in the past. Also, you guarantee performance, and in many cases, you can have an extended warranty. What it means is that from the day that the network is installed, you can get confirmation from the manufacturer that the network will perform. Before you can add, you add devices, and you add different equipment to the network. Next, please. And lastly, why the network is sustainable. As mentioned before, you can have less sport or use less space on floors. That means less energy consumption, which is that with the need of less device and equipment, you will use also less energy. You can have less infrastructure from the conduits standpoint, because in the different installation from copper, for example, you will have a lot of cable, and you will need a larger infrastructure. Also, you will have shorter copper runs, which means also in a better performance. You will have a smaller footprint. When you use a fiber-based infrastructure, you have up to 5 times less carbon dioxide emissions because of the less use of equipment, and obviously you will have operational cost savings. And this is all for the let's say the fiber portion. Let's talk about then for the new ways. Next. This is a next. Yes, thank you. And next one. Let's talk about class 4 power distribution shipping, which is the new way to power devices on a network. examples for what we can do with this class 4 power distribution system is a optical LAN network, or could be a distributed antenna system, the DAS. This is an example and what it is. Next slide, please. This is a new standard, UL 14.1, which was published on 2022. And let's say that this new system combined the best of the different the legacy systems, class 1 and class 2. And probably what we can say about this is that we make higher voltage safe. It's not a power limited and has a maximum voltage of 45 volts, 400 volts. And the way we call this is fault managed power systems. And when we talk about fault, we are talking about electric shocks and fire hazards. These are the main concerns about these systems and what we address within this. It doesn't have installation practices. I mean, it doesn't have to be installed by experienced or certified people, and it is not required to be performed by licensed electricians, as I said. Next slide, please. This is the comparison between the different classes. Class 1 and class 2 is the current and typical installation that we have within buildings and intelligent buildings and most of our installations. You can see here the different items when we can compare, and what we can say here is that with class 4 systems we can go in a longer distances and also run with a smaller cable. We can go up to 2 kilometers with these new type of power systems, and also the cabling could be between 16 and 18 AWG typically. Next one. This is what how the system looks like. We have a transmitter and we have a receiver. Between them, we have a class or the standard, as I mentioned before, is the UL 1400-1. We have the devices, which are the transmitter and the receiver, and between them we have the cable. The cable is also described on the standard. It's an end-to-end power delivery system. And as I mentioned before, the main advantage of this is that we can deliver power in a safe way and goes to longer distances compared to the current systems. The systems monitor faults, as I mentioned before, basically shock, power shocks, and also the fire. And this is what the system is monitoring every time. It's a secure and scalable and sustainable power system because it uses less cabling, sorry, and also it uses more simpler infrastructure than the current class 1 and class 2 power systems. Next slide, please. And with this, I turn to John.
Okay, thank you, Juan Pablo. I am so excited about class 4 powering. My position is that it finally unleashes fiber-based networks. So happy to see this innovation come to fruition. This is the Q&A. Well, hold it. Before we get to the Q&A, I wanted to just give you a little summary. So we started this out with the problem statement and the challenges of doing these smart buildings and IoT over legacy systems. You know, they're capital and resource intense. They're not flexible. They don't grow. They don't scale. They're complex, difficult to manage, etc. Hopefully you've heard from our expert panel how doing this and laying the foundation in an optical LAN, they can be less costly, simplified, more resilient, more secure, and now grow with the future demands. So hopefully we've made this all clear. And if it isn't clear, let's ask some questions to our panelists. So we do have some questions that have come in. But I want to give you time to type in some more questions. So as you start typing, perhaps I can give you just a quick overview of Apple LAN. So we're an organization. We do education and advocacy for optical LANs globally. We work with research industries and standards bodies to kind of shape the optical LAN industry. We write about it, we promote it. We have a strong marketing entity that is out there building awareness on it. And doing that is all part of the education, the training that we're doing with AIA and Bixby. So, you know, this is my chance to say, please get involved. Please join the Apple LAN organization, and you can find us in the www.applelanglobal.org URL. So with that, I have some questions here, and the first one goes to you, Paul, and it was if you could provide some cost examples for the differences between optical LAN and traditional LAN.
Sorry, can you repeat the question, John?
Can you provide cost differences between optical LAN versus traditional LAN?
Oh, okay, yeah. So that's a difficult question to answer without doing a design. But what I really want to touch upon with that question is that we need to look at not just the cost of the actual materials and the electronics for an optical LAN compared to conventional cabling. We need to consider things like operational costs as well, the cost of IDF closets. So by reducing the IDF closets using an optical LAN solution, there is a big cost reduction. And other key things like, you know, basket tray that's used to support heavy duty copper cables, we can eliminate a lot of that cost because we're reducing the amount of cabling in the horizontal space using fiber optics, and those fiber cables can actually be mounted onto and supported on JBook. So if we look at it from a percentage, there is a cost advantage using optical LAN, and that could be between 15 and 30%. In certain cases, it's actually more than that. But the other savings are the operational costs, and that operational cost saving could be anything up to 80% because we are removing all of those crack units and power requirements.
Okay. Kayla, I think we got a couple questions for you. One question came in about, are there standards for the software-defined switches that do support the PON and the Ethernet all in one?
Yeah, I mean, the switches that do both, they just, you know, either the software defined. So yes, to answer the question specifically, they comply with the standards, and it can either, you know, fall within the GPON or the Ethernet. And basically, if you're using a software defined switch, you can almost configure each port separately. So you can do them both on the same switch with two different standards, literally. But both Active-E and GPON fall within the TIA standards for structured cabling.
Yeah, I even would say by definition, a software-defined network is open source standards based. So
yeah,
absolutely. Okay. I'm going to give this one to you, Gayla, because I think it is, you may have a answer relative to hybrid composite cabling, but there's a question about our team doesn't understand how class 4 powering integrates with optical LAN. Can you elaborate?
So in my presentation, I was showing you, you know, the options of doing remote power. to power that optical network device at the end, the ONT. So what class 4 power does with class 2 or class 3 power, which is what we're traditionally using today, we are limited by the 100 watts of the class 2 power standard. So we then have to look at the hybrid cable we're using and the thickness of the gauge of the copper to determine the length. If you use a thicker gauge, you can go longer distances, but it is limited to about 600 meters. With the class 4 power, that really unleashes, as John says, the capability to really go longer distances, or even to put more power, and also to put more power over the cabling. So I don't know, Juan Pablo, if you have anything to add to that, but class 4 power really does help the sort of equation of how far away you can go or how much power you can deliver on the network.
Yeah, I agree with you, Gayla, and probably I would like to add that this is a centralized power system. So the idea is to, as you mentioned, power remote devices through the cable, and the main difference with compared to what we have in the currently is that they are safer, and we can go through longer distances. So that would be the way. Talking about the optical LAN, what we would want to power here are the ONTs, for example, through it, and it could be through a hybrid cable, as you mentioned, or could be in a separate infrastructure for a power cable and fiber cable as well.
And I see another question, John, about if this is what is called digital electricity. Digital electricity is a brand, actually, of one of the original sort of fault managed power solutions on the market. The more sort of generic term for class 4 the type of electricity is fault managed power, which is equivalent to this class 4 power, which has just become a standard.
Yeah, and it is would be good to add to that not all the systems in the market are class 4. You need to review which of them are classified as class 4. Some of them have some features and the things that a class 4 system have, but not all of them are classified. So you need to make sure that the systems that you are considering are certified. This is something that it needs to be reviewed.
Okay, I have another question, and perhaps I'll let both Paul and Mike answer this one. I'll tee it up to you, Paul, first. And that is, where are you seeing traction with optical LAN and smart building? What are the market verticals that are most receptive to going towards this fiber-based infrastructure?
All of them, in a simple answer. I mean, obviously, there are some key advantages with this type of technology in verticals such as hospitality spaces. I know that hotels are now adopting this technology at a much faster rate than other key verticals. We are seeing traction in higher education where we've got campuses, primarily because we can now run the cables over longer distances. We can manage the network from a central single, pane of glass. So that is another key opportunity for us. And, healthcare has been slower to adopt the technology. But in the commercial space, a lot of DIRT's businesses in the commercial space, and that, we are seeing that. Mike, is there anything else you wanted to add on to that?
No, well, yeah, I mean, so education, campus, and hospitality is definitely, if you look at any of the literature, and that matches up with our experience as well. Large corporate, so owner occupiers who own, a very large building or maybe multiple buildings, so kind of corporate campus. We're seeing interest there. We've recently had interest from like warehouse and logistics client, big global warehouse and logistics client, having conversations about, needing to put connectivity over a really wide area, but not needing a lot of density like you'd have, for instance, in an office space. So that's an interesting one that we've seen interest in recently. And then from the smart building standpoint, or the smart building side of that, certainly, again, the workplace environment is probably the commercial real estate, commercial workplace is probably the largest leader there. With, I would say, owner occupiers having more interest because they get to realize more of the benefit. They get to realize the benefit that it brings to the people in the space because it's their people. So those user experience and process efficiency benefits. And then they're also realizing the benefits of the building systems themselves and the cost savings. But also we're seeing a lot of interest from developer-led projects as well. Especially on the side.
We always get asked as well is, what is the typical size building that people should now start to consider optical LAN as the solution? And again, we've done small projects, where we've got a small footprint in office space, and we've deployed optical LAN in those environments. So, all verticals are really now looking at this as a viable solution to be future ready. That's what they're really looking at.
Yeah, I think that the future ready part is a really good piece of it, because one of the things we're seeing is clients looking at it and saying, if we want to put in one infrastructure now, and especially from a cost and a sustainability standpoint, they want to know that 5 years from now, 10 years from now, they're not going to have to rip and replace. The ability with optical LAN to have multiple generations of bandwidth and throughput on that single fiber. When you install 1 gig and later you realize you have applications that need 10 gig, those can live on that exact same cable. You're just looking at what active electronics you have. So when people start thinking about, I know you hate to say future proofing, I do as well, but that expandability, knowing that you can upgrade those electronics without having to rip out your passive infrastructure, makes that a better investment.
Okay, we're at the top of the hour. I want to squeeze in one more question. I'll assign it to myself. And that is, are the remote powered ONTs different than the local powered ONTs? And the answer is no. These ONTs, check the manufacturer specifications, but these ONTs perhaps may have a barrel connector for local powering, and then they may have a Phoenix connector for tying down remote powering. And typically it's on the same ONT, so you don't have to pick and choose which ONT you need for local versus remote. Okay, with that, I want to be respectful of everybody's time. As a reminder, this webinar has been recorded. A replay will be provided. And please encourage your colleagues to also view this replay at their convenience. We appreciate you joining today. I want to personally thank Paul, Juan Pablo, Gayla, and Mike for sharing their knowledge with you today. And we look forward to seeing you on our next Apple LAN webinar. Thank you much. Have a great day.
Thanks, everybody.
Bye.